Eugene and I are going to talk about a topic quite complementary to what Bill just covered. We're going to be coming at it from the unsupervised training approach to machine learning, but converging on the same approach of non-keyword or at least non-Boolean search. We're going to talk about how semantic search has been promised for years, for decades, and it's all been lies until pretty recently. So I'm actually working at Basis Technology because I was a customer. My last 3 jobs at Verity, at MarkLogic, at MongoDB, we were all these companies were customers of Basis Technology. And I think actually my CEO got tired of having me as a customer, so he hired me. But this is going to be reflective of what I learned over those years, that we really were in a wilderness of semantic search, and it was being falsely promised. Anybody remember this engine? You were going to ask Jeeves a question, right? My favorite, I learned to reveal how these were lies, by the way. My favorite question to ask Jeeves was, how high is Mount Hood? What do you think Jeeves answered? Buy real estate near Mount Hood. Didn't really work. In fact, this was my general approach. That was particular to ask Jeeves because it's supposed to be question and answer. If you're confronted with a semantic search engine, what do you search for, assuming it's not plumbing? Toilet plunger. Just try it anytime somebody offers you a semantic search engine and see what sort of garbage it gives you. To pick one of the competitors I worked against, which turned out to be a fraud not merely in technology, but on the business side too. Their CFO is in jail in California, and their CEO is evading charges by staying in London. Autonomy offered semantic search via a bunch of schmumbledy-gump about Bayesian. Wasn't clear what the heck it meant. Search on toilet plunger, hit on a document. Highlighted phrase, several trucks were burning by the side of the road. At that point, I don't even need to say anything more. So what we did find was use of very complex Boolean searches. I was dealing with a mix of law, Bloomberg News and Bloomberg Law, and the intelligence community, DIA's Web Intelligence Search Engine. And in both of these, you would find very long, complex, up to like 14-page long queries written with ands and ors and keywords. These were curated over the career of an analyst. The analyst would pass on the query to their child when they gave their child their job. Troubleshooting these, we would spend a day and a half troubleshooting, why am I not getting any results on Russian armor production? And this was the early aughts. Well, sometimes the answer was, oh, page 14, one of the terms has changed in the standard boilerplate for that message format. The other one was, yeah, the Cold War's over. The Russians weren't producing many tanks in that era. But it would take a day and a half to even get there. General question, what do you do if you don't really know what you're searching for? You know mostly what you don't know you're searching for. Go ahead.
I guess you could categorize the data and then manually review it, or use magic.
Well, I think we actually had both of those to some degree being used. I'll just give an example here. Anybody know what that little red sock-shaped geographical object is? It's known as the 9-dash line, because that's the way it was drawn on an official Chinese map. That is the Chinese claim for the South China Sea, going basically just taking the whole thing and every island they're in. So a common problem in the intelligence community was a desire to search with a restricted context. In this case, I'll take that as the negative. I don't want South China Sea because I'm a China analyst. I'm interested in everything else about China except South China Sea. So with two different search engines, Verity and MarkLogic, we had to do some maintenance of the guts of it to support a query like this, saying, I want to find China, but not in the context of China Sea. In other words, that's a hit, China, Natch. That's not a hit, it's South China Sea. So it doesn't get selected as a document. Is that a hit? Yes, it contains South China Sea, so that's not a hit, doesn't get bolded, but it contains China not in the context of South China Sea. So this isn't and not, it's but not. This is the sort of complexity we got into trying to handle these problems during these years of the wilderness. I'll give one more example of the wilderness where Microsoft 2006 was showing off this semantic search where you could ask a question, get an answer. And I never actually got a chance to try toilet plunger on it. All I know is shortly thereafter, they bought the company Fast because their search was completely inoperable. So all I know is that it didn't really work. Anybody know what from business standpoint, how Fast worked out? Kind of like autonomy, the Norwegian Financial Police showed up the week after Microsoft bought them. Thank you.
So my name is Eugene Reyes. I've been a software engineer for more than 20 years, more than half of that actually in the intelligence community. So I come at this from a little different background than Chris. But anyway, so on site, kind of like what Chris was alluding to earlier, I've worked with analysts and targeters hand in hand to see what they do day in and day out, basically what keeps their lights on. And what they end up doing is they create all these very long and diverse Boolean queries. So the thing is, if you think of a Boolean search over there as a hammer, you think of everything as a nail, and that's the way you'll be able to solve it. So we've been conditioned to think, what's this? Boolean search, right? Yeah. So people have started thinking, oh, we need to have everything as a text box there to solve every possible issue that has arisen in the intelligence community. So what happens is, let's say you're looking for something kind of, you could say, simple, like this. It's a nuclear explosion, right? What would cause it? A nuclear weapon. So by doing a Boolean or keyword search, you would start with, let's say, nuclear and weapon. But then if you want to start adding a little diversity and looking for things like nuclear bomb, you might say nuclear and weapon or bomb, or have two different phrases in quotation marks. And then to expand upon that, let's say you want to say not just nuclear, but thermonuclear or warhead or bombs. So now you can start tacking on all these ands, ors, and sometimes even nears like plutonium or uranium. And you can kind of see how this becomes very complex very quickly.
And these are simple searches. Lather, rinse, and repeat until you get to 14 or 20 pages.
Right. So how many of you here have actually heard of needle in a haystack? Show of hands. Everyone, hopefully? Okay. So how many of you have actually heard of needle in a needle stack? Not many? Well, here's a needle stack. Let's see. Let's try finding things in here that are important. Well, the catch is everything in this is important. But what is most important to me? So let's kind of use a real-world example. So last month, you might have heard this on the news that Abu Bakr al-Baghdadi was killed in October 2019. Imagine if you took every file that he's ever created on a hard drive, thumb drive, CD, posted on social media, what have you. You would think everything's important, but how would you start going through it? We need to go through it very quickly, so there's a timeliness to it. So the intelligence community would have to go very rapidly on it. Now let's back that up to, let's say, Osama bin Laden back in May 2011. So those files were very important that we captured, but if we start trying to do analysis on it now, it's not as timely as it was, let's say, with al-Baghdadi just last month. And the main point for this is, if you actually remember about the search results you get from Boolean search, it starts becoming too unwieldy for just one person and requires further analytics to help solve the problem. Like a pointer problem.
Only I didn't just lose focus when I did that. All right, what can we do to improve keyword search? And actually, the question answer there somewhat stole my thunder. One of the things we can do is what became known as faceted navigation, probably most popularized by Endeca, but has become a standard of any text search tool. We will take what is an otherwise large set of results, so do some query that gives us high recall, but maybe low precision. There's no way I'm going to go through all 104 of these looking for the particular Wordsworth book that I'm searching for, but that's okay. Maybe it saves me if I can go over here, look at refinement based upon some sort of taxonomy or ontology, some way of organizing the data. But wait, what if I don't know what I'm searching for? I don't know what my taxonomy is. I don't know my ontology. I don't know how it's going to be organized. Both legal and government intelligence, I could be in any subject area. Well, in this case, you can go to something called dynamic clustering. We'll take the actual result set itself, what this is 21 results here, and we'll use various approaches to create clusters of them. Anybody heard, speaking of that, of Clusty? Anybody been in this business long enough to remember Clusty? I still think of it as Clusty the Clown, but it was a dynamic categorization approach for search result sets. Anybody know what happened to Clusty? Where'd he go? It was a Vivissimo product. It was their web search exposure, but where'd it go? Believe it or not, okay, related question. What's Watson? What is Watson? Brand, exactly. It's a trademark. If IBM tomorrow decides that this is Watson, then it's a Watson presenter. It's whatever IBM wants it to be. So Clusty must have been burned out. They renamed it Yippee, and you can get this today. Full URL for this result set is there. But if you just look for Watson Yippee, you can get this today on the web. I don't know who actually uses it, but it's helpful in that it shows where the limitation appears with clustering. You still get a lot of garbage. Notice here we got dies, eating, and this is actually right on the money when a dugong, type of manatee basically, dies from eating plastic, or a turtle dies from eating plastic. But then it starts to degrade down here. We get into die cutting. Okay, we got synonyms of die, and we wound up with low quality results. But as limited as these may be, I don't offhand know of anybody who routinely uses dynamic clustering. These were at least attempts to deal with the problem. Meanwhile, as we were honestly floundering with keyword-based search, progress was being made.
So over in the intelligence community, I worked with several experts actually on LSI, or latent semantic indexing. So what that actually is a multilingual approach or mathematical approach to solve, or at least be one solution to semantic search. So it identifies patterns between terms and concepts in text. So the way you express something is very similar if you switch out one word with another. So it was computationally expensive, but it was viable in two communities actually, the intelligence and in legal discovery. So with this, we found out in terms of the intelligence world that it was great in two main areas. The first one was topic exploration, kind of a stream of consciousness. What am I thinking? I can start describing a topic and will find relevant documents very quickly. And the second one was about detecting coverage gaps. So a lot of people, a lot of analysts and targeters on site would have to know, like, okay, I am focused on this particular part of the world with this particular topic. What am I actually missing? I can provide my prior reports, emails, Skype messages, etc., and try to find things that are very similar to what I am interested in and see, yes, I've covered everything, or no, there are a lot of other documents I need to read and actually report on. So LSI is actually great at clustering as well. So this is one example of how to actually visualize a cluster for LSI. Unfortunately, LSI is really geared towards 300 dimensions, so it's a little hard to take in by just visually very quickly. But this is a 2D representation of it. So you can see like there's children, culture buffs, frequent travelers, etc. But then you see there are these two clusters about health risks and shopaholics. So how many of you actually have heard of retail therapy? Anyone? Okay. How about buyer's remorse? So that could actually be that little teeny overlap right there between health risks and shopaholics. So basically what I'm trying to say with this slide is that you can find things, and you have to remember that there are more tools on your tool belt. You don't have to be limited to just keyword search or supervised machine learning, as Dr. Dim said. So you can also use semantic search and other approaches. So one way to do it.
Actually, let me just add a little bit there. The methodology that Eugene showed was latent semantic indexing. We're not going to go into engineering details here, except say, who here learned about and remembers how to do eigenvectors? You think you could do it if I gave you a problem? You could. Yeah, I learned it. Suffice to say, it's based on a complex technique of isolating values, in this case semantic values, from noisy data. Concurrent with this evolution was the appearance of another technique which has largely taken over from latent semantic indexing. This technique starts with research done, some breakthroughs really in neural networking. Neural networks were kind of dead. They weren't making much progress, at least not visible outside a little research community, until it's usually traced to a Microsoft paper in 2009. Suffice to say, there's this breakthrough in a method that doesn't require the sophistication or even the computational complexity of LSI. These engineering details we're not going to go into either. But just to broadly think about this, if we look at every word in a language as a dimension, how many words in a language, a typical human language? That would be like in a vocabulary, but in the whole language, it's, yeah, it's going to be a number, and you get into all sorts of navel-gazing stuff about, what is a word? But yes, it's in hundreds of thousands, call it a million just for round numbers. We're going to take those million dimensions, and even a modern computer doesn't work very well on that many dimensions. It's called, the problem in computer science is called the curse of dimensionality. And we're going to squash them down. Used to be latent semantic indexing, now it's typically deep neural networks. Squash them down into anywhere from 150 to 300 dimensions. Still too much for a human to deal with, but computers can handle a certain class of problems, including these, pretty darn well. So again, this is just a high-level engineering. Suffice to say that this technology has been democratized since 2009, and we've learned to really make it do tricks.
So I'm actually quite new to Basis. I joined earlier this year, and one of the reasons why I joined was because of the work that's been done with neural networks, specifically for text and word embeddings within Basis. So one thing that I was able to put together over the past few months is a prototype, or you can say a demonstration application called Semantic Studio. So here's the application. So all you have to do is basically type in what are you thinking at the very top. So stream of consciousness, you can put in, just start typing in. Doesn't have to be complete sentences. It could be emails or reports, or in this case, what I did was I actually selected the text, the first few paragraphs from Wikipedia describing nuclear weapon, and just dropped it right there. So you see there's no formatting, no syntax, no ands, or, not, nears, anything like that. Just taking the text as is. And then I did what we call a semantic query into all the documents that I have access to. So this application allows you to see, touch, and play with the actual embeddings, so you can kind of get familiar with it and build trust with the output that's coming out of it. So to expand upon it further, we can also go across languages and find similar terms in terms of how they're used. So in this case, I typed in the word spy in English, and I just selected Spanish. So these are all the Spanish terms that are very similar to the English term spy. So you get some of the usual suspects like, you can see CIA in there, but also there's other things like misterioso, like, mysterious, or mercenary. So these are words that are kind of used in similar ways in Spanish to describe the English term spy. So now we can start tacking on from there and build upon this. So instead of just Spanish, we can say, here are some Arabic terms that are also similar to spy, or even some Russian terms. So we can use that and try to find things that are similar based on the way they're used. So let's let's take one different approach here. Let's say you had to deal with a lot of legal terms or jargon. Let's say, in this case, how many of you have heard of collusion in the news lately? Everyone, hopefully? Okay. So how would you describe collusion without using the word collusion? Well, here you go. You can say like it's involvement, complicity, bribery, connivance. So it's not just a thesaurus, it's also how words are used along with the term or text that you're actually putting in.
And Eugene, we're going to deliver a 2-minute warning to both benches.
Okay. So just to wrap it up very quickly. So this article right here was from the Voice of America. If you attended Chris Bia's presentation earlier this morning, you're probably seen this earlier about Russian influence operations taking aim at the military. What we can do with semantic search is actually take this article as is and start searching other documents or news sites that we have access to. In this case, on the right side, you can see RT, which is for Russian. So what we're doing is taking an English document, searching against Russian documents without doing any translation whatsoever. So we put that through Semantic Studio, and then we can see that the title of it is called In Search of the Russian Trace. You can see the quotation marks connection between the hacker group in Moscow by the intelligence agencies. So that's theirs, not mine. And if we look for the actual paragraphs and sentences that are most closely associated to that Voice of America article, the top one is actually talking about how the Russians are saying the publication of our reports are part of a political campaign to create in the minds of their citizens. So you can kind of see it's kind of pointing fingers at each other. So the whole one thing you can take away from this is that semantic search can not only find related documents of interest, but also identify texts that can support or reject conceptions.
Thank you, Eugene. And
Yeah, do you have any questions for any of the three of us?
So you said you reduce it to 300 dimensions.
right.
Is that you said LSI tool had 300?
LSI was one way of doing it. Now it tends to be done more, and our particular technique at Basis is to use deep neural networks. But either way, the key is to squash it into 300 dimensions so that you're preserving the semantics. And this is, I'll emphasize, this is not machine translation. This technique is used in machine translation. It only solves about 10% of the machine translation problem. What we do here, though, is without having to do machine translation and suffer all of the inaccuracies of machine translation, we can take the semantics and apply it across languages.
Is that the big breakthrough that you're doing is happening?
Yeah, the breakthrough actually was there with LSI. That technique was adequate. For a number of market-related reasons, including the sheer expense of the hardware to run it on, it didn't see broad adoption. I can think of one vendor that really used honest, effective semantic search 10 years ago. They found limited success in the intelligence community and legal discovery. But it really wasn't ready for broad market. Yes?
Are you doing anything at all with transformational grammars that can be generalized across multiple domains?
This is not, and this is where you get into the rest of what would be needed for machine translation.
Yeah.
This does not leverage transformational grammars, and I have to distinguish this between transformational learning, which is related. But it would be an interesting research topic to take some of these cross-linguistic capabilities and try to wire them in. At the moment, we are just using words and n-grams, phrases of so many words. But to try to pull out some of the higher level syntactic constructs of the language and use them would be interesting.
So when you say words, do you mean just nouns and noun phrases?
No.
Or-
No.
Okay, so verbs and adjectives also.
Verbs, adjectives, and even particles. When you get into speech to text, the first thing people do is, oh, let's stop word or No, don't. It has semantic content.
Yes, it sure does.
We have time for one more question, and then after that, if anybody's going to the e-commerce session, it's next door. So if we're thinking of going there, I am going to run over there because I'm.
All right. So I'm going to direct you all over there in 3 minutes.
Is there a data structure advance between latent semantic indexing versus neural networks, or are they, to a layman, are they kind of the same?
Yeah, the data structure is stupid simple. It's just a vector of 300 numbers, usually normalized on a -1 to 1 interval. Now, there's a little bit of sophistication in how you cluster it and measure distance, but even distance is cosine similarity, which is, you know, kind of the dumb way to do that too.
Is distance the same as the strength of the?
No, if you take two vectors, you would compare them with cosine similarity, and that would give you a distance metric. So you would expect, for example, man and guy in English to be close, and then hombre in Spanish and homme in French to be fairly close also. Any other questions for any of the three of us? All right, please proceed out the door and to your right. We're going to single track from here on the rest of the day. Thank you very much for your time.